Okay, these are notes on comparing a paired t-test to a two-sample t-test. In other words, two separate groups of means. So here we have two separate groups of means, whereas on a paired, we were actually taking a before and after or a paired data set, and we actually made a single mean. All right, we put, even though we had two lists of data, and maybe one in L1 and L2, we subtracted them in L3 to came up with a single list. Two sample t-test is used to determine whether or not there exists a difference between the means of two, this is very key, independent groups. So we have two separate groups, whereas in paired data, we had some sort of relation, a coupling of groups. So the most difficult thing between paired and two sample is determining which one it is, because they're very different tests. Both are easy to run, but they're very different. So how do you determine which one to run and when? So we often have two groups. If we have two separate groups, this is better. This is more likely going to be a t-test, a two-sample t-test. So when we have two separate groups, we take the average of one group and compare it to the other average of the other group to see who did better or worse or the same. That's going to be a two-sample t. Whereas a paired, I'd be testing someone before or after. So let's talk about a paired data, because that's probably the more difficult to determine, which is why we did this first. Some subjects are tested before, after the treatment is given, or we have a subject tested twice. They receive both treatments, as in the mosquito situation, where they put one spray on one arm and one spray on the other arm. Sometimes we have special situations where we have natural pairings, such as twins, and we'll compare one twin directly to their own twin, not to the group, but to one twin. We may test spouses, so myself versus my wife, not married men versus married women, but each a married man versus his wife compared to his wife. We may actually do siblings, where a brother is compared to another brother, or a sister to another sister, or a sister is compared to a brother, but it's not kids from multiple births. All right, we just comparing one to one. You're going to know if it's paired if the data length is, if it's not the same length, it can't be paired. All right, just because it is the same length doesn't mean it is paired, but if it's not, it's definitely not paired. On the other hand, two sample t-tests, you have two independent groups, and it could be married men versus married women. And you're comparing the average of one group to that of the other, the average of married men IQ to that of married women IQ. Obviously, you may have more married men in one group and more married women in another group. They don't have to be the same one. Again, the difference between this and a paired, and since we're talking about married men and married women, is in a paired, you'd have to compare the actual individual spouses. So myself to my wife. Here you have a group of married women and a group of married men. You take the average of the group of married women compared to the group of average men. So let's try a couple of these. As soon as we start doing a few of these, this will begin to make more sense. So an experiment measures people's lung capacity before and then after an exercise program to see if their fitness has improved. So here we say before and after. So I'm measuring someone twice. Because I am measuring them twice, it sounds like this is going to be a paired test. And to see if it improved, this has a direction. So this means because it has a direction, this is going to be a one-tailed test. All right. A different experiment measures the lung capacity of one group who took one exercise program and another group who took a different exercise program to see if a difference in outcomes existed. Well, here we have two independent groups. One's taking one exercise program and we're comparing it to another. So the average of one group to the average of another group. So this is going to be an independent two sample test. And we're looking for to see if there is a difference, and that's going to be not equal. And not equal is a two-tailed test. You want to see if an education program will help raise your test scores. Your experimental hypothesis is post-training scores will be significantly higher than pre-training test scores. Is this paired t-test or two-sample test? Technically, this could be run as either, but because I have a pre and a post, it would be really advantageous for me to do this as a paired situation. And we can justify it as such because someone was tested twice, before and after. What was their score before they took the program, and what was their score afterwards? And since it was given a direction of higher, this is going to be one-tailed. This will be a one-tailed test. All right, for the next ones. For each scenario, determine whether it'd be more appropriate to use a two-sample T or a paired test. Compare the average height of men and women. We didn't say spouses, so we're not comparing couples, we're comparing groups. So since we have two separate groups, this is going to be a two-sample T. And I'm just going to put a 2 for two-sample. Compare the weight of spouses. So I'm assuming this is one spouse to another spouse. So a male, my wife to myself. So this would be a natural coupling or natural pairing. So I'm going to call that a paired. Compare the BMI of teenagers to that of adult. So since they didn't say that this was the child and a parent, I'm going to say we have two separate groups. And since we have two separate groups, two independent groups, I'm going to say this is a two sample. Compare the cholesterol levels of a child to that of their parent. Well, now we have a pairing because I'm comparing a parent and their individual child. So this is a pairing. It's a natural group. Compare the blood pressures of patients receiving drug A to those receiving drug B. We have two separate groups, two independent groups. And comparing the weight of dieters before and after a diet. Because we have a before and after, we've collected the data on someone twice. And so that sounds like that is also paired. So basically, if something's tested twice, we have a natural pairing. It's probably going to be a paired test. If we have two independent groups, in other words, there's not a natural relationship between them, then we're going to be looking at a two sample. Okay, that's probably the most difficult thing that we're going to be working with when we come to two samples. Other than that, this will be very, very similar to what we've been doing before. And we'll watch some, we will go, the next videos will show scenarios on how to do that.